Good afternoon, everyone. In the today's session, we would like to continue regarding the CSC milling machines. As we have been seeing the basic introductory part and the classifications of the CNC milling machines and different types of CNC milling machines existing in the environment. In the today's class, we would like to discuss regarding the CNC milling machines, work holding devices, and the tool holding devices. So as we all know that CNC is nothing but the computer numerical control technology, which is quite opposite to the conventional mode of getting work done. And access the work with precision orientation, good geometrical specifications, and that too within the less time bound or less time period, with increasing in the quantity of production. So in this class, we have been discussed in detail with respect to the topics that semi-automation in the case of the CNC and automation, complete automation in the case of this CNC. So in the semi-automatic, there's some time lagging in order to change the work part to be fixed and removed from the jigs and fixtures, and tool bits changing within the tool post for exercising in the machinery for different kinds of operations, facing operations and slotting operations, reaming operations, finishing operations, etc. Hence, it takes a much time period for changing manually both this work part from the work holding devices and the tool from the tool holding devices. Hence, in the case of this automation technology, complete automation technology, automatic tool changer and work part mover within the conveyor belt and automatic tool changer based on the type of working process that to be confined plays a major role of performing the activities very much fastly and with respect to saving of the time and getting the task in an appropriate manner as it completes the work within the less time period. Coming to the work holding devices and tool holding devices, how it will be getting differed, what are the feature characteristics, and how subclassifications it holds the objects within the vices, and how these work parts which are getting hold within the vices get supported for precision oriented working processes and getting the final output of product will be discussing in detail in the today's session. Initially coming to the work holding devices. So typically we are having different kinds of this work holding devices for arresting the work part without changing its dimensions or actions from one position to another position. And nominally, we are having these work holding devices such as vices, which are a permanent statutory for fixing the objects, a clamps modular fixturing system, indexer or rotary table with respect to holding concept of magnetic system, the chuck vacuum, chuck freeze, chunk, and the dedicated fixtures. These are the some of the work holding devices utilized for holding the object and performing the task over the milling machinery. Coming to the features of this work holding devices, it helps us the proper part immobilization during the work commencement and accessibility to the machining area, accessibility to the machining area, the ability to observe the machining efforts. So you need to get shapen into the required dimensional accuracies for getting the better achievements of dimensions as per the vendor specifications. It helps very much comfortably. The minimum part deformations will be getting occurred instead of getting the maximum while the machining process due to the vibrations that has been occurred due to the frictional variations occurring by the tool over the work part. So this holding devices helps us to minimize the maximum vibrational capabilities and hence decreasing the deformations to a maximum level and hence will be obtaining the minimum part deformations in the case of this operational statistics. Next thing, short part clamping and unclamping timing will be getting confidency. As representing with respect to the white spaces, we're having permanent fixation strategy with respect to the bench cadre. Presently, in almost all the cadres or working environments in the laboratory process, etc., this vice holding devices plays a major role, that too commencing of small to medium range of parts on it. Here, the vice is being fixed with respect to mechanical actions as representing here is a plane vice. Upon rotating of this handrail, automatically this lever will be getting converged and object will be getting holded tightly. And this is a swivel based vice and this is a universal vice which is holding exactly upon fixation of this major bud at the finishing of the bunch. And in the advanced cases, we are getting acquired. Those are mechanically operated conditions, but most probably we are having different kinds of holding or guiding these work holding devices for very tight fixations within it, which are operated in a mechanical basis, hydraulic basis, and pneumatic basis. As per the mechanical basis has been considered, these are the universal vices, plane vices with respect to swivel base, and plane vices with respect to a manual rotation of this lever will commence the actions. Either as in the pneumatic vice or else the hydraulic vices. So in the hydraulic case, it is the pressurized fluids for imparting the pressure for holding the objects. Second thing, the The pneumatic vise plays a major role for holding the object very tightly, that too with respect to the compressed gaseous pressure or pressurized gases, compressed air or pressurized gases. There are different types of monitoring these vices in three different mode of operations based on its degrees of freedom in the sense number of ways of movements that need to be acted towards it, having the plane wise with the swivel base, universal wise with the swivel base. Coming to the clamp type of holding devices, basically these are used for very big size of parts, and the two irregular shape types of devices is used to hold by this type of accessories. Hence, the parts will hold very much tightly with respect to different characteristics by T slots as shown in the diagrammatical representations as in V block, C block, T slot bolts, T nuts, and in order to hold very much tightly these washers fixations as shown the complete fixation in the case of this tau mold clamp, angle plate, step blocks. With the step blocks, upon fixation, it will be having and maintaining the linear representations towards it for holding the objects very tightly. And V block is to tighten with respect to the screw pin and making a non-movement of this cylindrical bar. Moreover, we have to fix one disadvantage strategy in the case of this clamping type of system, because by considering these kind of activities or holding the objects for the commencement of work processes, the deformations will be getting taken place over the objects. Hence, see here for example, on the V block, the cylindrical object is being lying here, and indeed to arrest this object, a lead screw is get and tightened towards it, which doesn't give the motion towards this object. Hence, the surface of the object will be getting deformed to a slight variant. Coming to the work holding devices in the case of this modular fixturing system. So modular fixturing system, in the sense, this is based on a grooved base plate or else a drilled base plates. Grooved in the sense will be having a particular representations with respect to different significations. It may be having a drilled type of situations or grooved type of base plates, which is having a good versatility, nothing but having it's flexible for moving from one place to another place and holding the objects from one sector of division to the another sector of a division, considering of the vertical extension or the radial locator. Coming to the indexing head or rotary table, as these are monitored with respect to two different conditions. It is a manually operated strategy, as we are having this motor driven, which is commonly used for machining angularly the equidistant surfaces, common distant surfaces, which creates a parallel gear cutting system by maintaining the similar profile axis, and hence the chunk that allows to hold and rotate this work part, which is working at nominally different angles. Similar clamping possibilities to process the turning. So hence here JNTUK plays a major role for holding these objects, that too between the chuck and the center and in between the different centers of the objects. The next type is that magnetic chunk. Particularly, you'll be having the ferromagnetic parts which are inducing in order to hold without having a movements, getting a magnetic power in order to hold the objects very much tightly. Hence, we can say that very much powerful of holding capability. Usually, we'll be having electromagnetic activation system also for its conduction and processing of work very much easily without having any of the movements misleading, that to misleading. And here the part centering may be a time consuming process. Coming to the vacuum chunk, is ideal for thin and flat metal sheets, the non-porous surfaces, hold down the forces for not extremely very much height situations, but having capability of lifting towards some extent, but not a maximum high provision. Particularly, the equivalent or uniform holding pressure that on entire the workpiece surface will be taking place. The coolant can be used without affecting the chuck performance, because the temperature will be getting produced upon the inducing of this vacuum sink, and coolant is used to reduce the thermal stresses or else the temperature stresses. Only the freeze chunk, particularly these are used for holding only the mini or small work pieces that were having a less tension, or we can say simply that no tension that will be built within that particular workpiece. Even the clamping time will be of plus or minus 90 seconds and holding the precision of plus or minus 3 micrometers only. And to the dedicated fixtures which are utilized for setting the desired inclinational factors, that is a custom designed fixture. Capital investment must be observed by the job. Nominally, it's used for medium and big batch production runs. Those are the different types of work holding devices for the commencement of the works in a prescribed manner as per the vendor's requirements. Come to the tool holding devices. These are classified into different types. First one is the tool holders, spindle type of tool holders, extension adapters. This tool holder devices again subclassified into different types. Those are Weldon or whistle notch ER system type of tool holder, collect chuck type of tool holder, power chuck hydraulic chuck, shrink pit utilized for thermal related, capable of thermally holding objects, nothing but temperature holding objects. Save lock tool holders, polygonal clamping type of tool holders. Coming to the spindle type, ISO or BT, HSK, Capto type, Big Plus, and KM types of spindle type of holding. Directly the tool is fixed in the spindle and the orientation or rotation will be getting progressed over the work part as per the geometry that has been specified for getting the work progressment. Coming to the extension adapter, this completely initiates the length of its holding capability, and by holding the work tool, it will be getting extended in 2 degrees of freedom, either in the positive extension and negative extension, compression and retractions. Nominal tool holders, there is an Weldon or whistle notch type of hold devices as represented clearly in the pictorial representations. These are the Weldon types where the complete spherical orientation body will be fixed in the chunks and progress of work will be getting taken place. And whistle notch, where one type of whistle notch will be getting assisted for removing and compressing of these lock nuts. Here collect checks will be having an arbor type of nature used to hold the work part under it. This is the power chuck, utilize it for holding internal alignment towards it and have a good grip and good straight oriented cutting factors will be getting done. A hydraulic chuck utilizing for holding with respect to an fluid bar, shrink foot, which is having the capability of operating at an different temperature maintenance by maintaining the different temperature strategy. These are the tool holders which is having the relay of holding threading capabilities, the safe locks for conditioning the locking systems, because in the working scenario it gives the production not to let out or pull out while the process is being commencing. Moving on to this polygonal clamping. These are the steps that we'll be having with the different shapes as per the design orientations or holding orientations, having different types of steps. And coming to the spindle type, ISO, Indian Standards Organizations aspirate, the locking will be considering from the fixing of this arbor holder to the tool holder, the first step, and HSK type, There is also a counter positions towards this ISO type. Capture type holds to a different structural, but a locking knight helps us to hold the work tool which has been fixed from the arbor to the tool holder very much tightly. This big plus or ISOS KBT is having a holding capability of fixed strategy with respect to gasket fixation in the case of this big plus and minimal error identification in the case of this BT type of system. And the KM will be having ball finite systems which holds within the object while converging, and while it has been inserted towards this, that balls will hold the locking and create as a locking system and holds the objects very much tightly. From the spindle type of holding devices is the fixation capability and have the analysis on different types of motions creating as per its specifications of fixing capabilities. And the green color segment gives the clarity of extent fixation, yellow color optimum range, red color not acceptable. So here in the bending type, cantilever beam type, initial strategy it is fixed, okay, and here it is optimum, and in the case of this torque, nothing but the two in locking type of this notch type and plunger type, and this is a wedge type, and remaining three agitations it has been accepted, excellent. There is no any deformations in the tool holding capacitor in the case of this bending system. So heavy loading characteristics. Coming to the torque, either clockwise or counterclockwise. Big plus mode, it is accepted. In the ISO mode, it is accepted in the torque mode. And HSK mode, it's not at all acceptable. In KM, it is optimum. And in Capto, it is not suitable. In the case of this repeatability or precision, this big plus will not accept, and ISO is not at all accepting, HSK not at all accepting, and in the KM it is optimum, and Capto it is excellent. And in the radial deviation, the ISO is optimum, and the rest of all the four parameters it is excellent. In tool changing in almost all the systems or almost all the types of spindles, it is excellent. So these are the extension adapters which has capability of exceeding and getting the contouring positions as per the geometrical specifications. And it gives the overhangings, over extensions from one face to the other face. There is a slot basis of holding by submerging towards it and extension towards the work phenomena with respect to the tool and work part engagement in order to get the particular shapes as per the desired specifications or desired geometrical conditions need to be achieved. So coming to the machining operations, we're having different kinds of machining operations. In the case of this milling machine, let's have the classifications in detail one by one. Face milling operation, high feed milling operation, shoulder milling operation, slot milling, cutting off, chamfering, profile milling, turn milling, plunge milling, propodal milling, circular milling, linear ramping. So ramping in the sense we are all aware that applying of a pressure minimally to some extent. Linear ramping, circular ramping, and thread milling. These are the different classifications of these milling operations that are being performed in the CNC versus and nominally completely automatic strategy or else the semi-automatic strategy of milling operations conditions. Coming to the face milling strategy, it's a general face milling process which use the tools upon fixing with respect to an auger or tool holding case that process the work over the work part for getting the finishing stations. See here, the general purpose of face milling cutter, with which it is utilizing a 45 degrees entering of the angle, and face milling cutter with the round inserts for getting the tough conditions. Particularly this face and square shoulders milling cutters having this light face milling operations towards it. Particularly used to call this as a slab milling process. During the high feed milling, particularly utilized for the machining operations, conditioning is processed with respect to low entering angle at 10 degrees of inserts, high feeding, and low cutting depth. In the case of the shoulder milling process, square shoulder milling is also used for face milling and even face milling of the thin walls. Most probably, this process is used on heavy kind of machining processes, heavy kind of machining strategy, where the tools will be getting fixed over it and removing of the material and the conformity accessories. These are the light shoulder milling operations which are having the cutting sections particularly used for shoulder milling process. These have the capability of conditioning by getting a good finishing structure or the surface finishing after the removal, and even rough type of strategy in the case of this milling. Machining operations, we are having different types of machining operations in the case of this slot milling processes, which is subclassified into two types. First one is the end milling process and side and face milling operations. See, this end milling process, which with the extensible range, the solid cabbage will be getting ahead and removing the material for a long edge milling cutter by removing the material towards the other slot area. And this is the conical shop that is being added. And this is the end milling process will be getting processed right from the starting range to the ending range. And these are the contrapositions that are also possible in different orientation shapes. And side and face milling strategy is having horizontal milling machine and vertical milling machine. Both are preferred for getting this cutting process. See here, generally commonly utilized components will not be had in this rotation strategy, and how hence we are utilizing the slotting or parting of process by different tools, that too for commencing the work progress of the over the work part on the external and shallow grooves and slotting processes. Mixing operations between T-slots milling and helical slot millings. So T-slot millings in the sense particularly having the over the workpiece, the initial slot to some change in its deformation of or up to a particular length will be having conformity, and next rest of the part will be having with respect to different diametrical source will be holding with respect to an gear characteristics within slot attached with respect to the end of the shank. For continuous chip morphology or elevating of the chip or evacuate of chip, this T-slot machinery plays a major important role. For the case of this helical slot machine, it requires a coordination between this rotational speed and feed per revolution, because a slant cutting plays a major role of work for getting the good or accurate profile finishings. These are the different types of work progressments considering. And in the today's class, we have done. Let's review three different charted of points: work holding devices, work holding tools, and different types of milling machine operations that in depth will be moving in the next class.